All right, let's get started. Today, we continue our Pathway to AKS series, and I'm going to deploy a cluster using Terraform. And no guests, just me and Kev. What's up, Kev?
I'm good, man. I mean, this is like Robin's debut. Like, I honestly, right. And just to make it perfectly clear, I would say Robin's probably the more technical out of the both of us, right? He's, elbows deep in code these days, right? So it's his debut. He's been busy, but he's going to do some Terraform goodness today. And it's coupled with AKS as well. I mean, what else could you want, right? So,
what else do you need? Right. Anyway, no pressure.
No pressure. Sorry, just to put that mountain of pressure on him. But you got this, Robin. You got it.
We'll be fine. Let's get let's dive right in. Right. Let me share my screen. I'll move this to here. Otherwise, you get that screen in screen thing.
What is it? Inception, right? That's what they call it, right?
Yeah. Let me open up the portal already. Let's close my mail. All right, let's get started.
I love these technical sessions. So I'm going to try and ask as many stupid questions as possible as well, right? So let's go for it.
So, see my screen?
I can see the famous Azure portal.
Is it readable, or should I zoom in?
It's a bit small, I'll be quite honest.
What about this? Better?
Keep going.
Keep going? Oh, man, this is for... Nah. 1 out of 10 is what we're going to do.
There we go. Let me just put my glasses on. I'm only joking. Go on.
Yeah?
It is a bit small, but I don't know if that's because I'm on a small screen, so it should be okay.
All right. Let's see. Let's see if it will be end this.
It's a little bit small as well.
Yeah. And this
Control and plus on the keyboard is your friend.
No, this is IntelliJ. I'm not sure if that works.
You're not using VS Code?
No.
Whoa.
This should be fine, right?
Is there any way to zoom in at all?
Well, what I can do, of course, let's get out of this.
I'm just thinking about the folks.
Oh yeah, of course. Let me get my OCD out of the way.
It's because Robin's got an 8K screen, IMAX. That's why it's so small.
Of course, come on. I do have.
There we go. Familiar face.
And here I do have this. Yeah, see, better.
Keep going.
Keep going. Let's do 125. Right? Why can't I do that? Input zoom. 125. There we go.
Yeah, that's looking good.
Let's set this one on 125 as well. Boom. All right, this should be good enough. It feels a little bit awkward, but we'll deal with it. Let me zoom this one in as well then. Oh, this is not the wrong. No, I can zoom this, right? There we go. Okay, I'll clear all this. Okay, so I did some homework. I prepared a couple of things. Let me open my GitHub.
Yeah, let's go through the scenario, right? What is it you're...
So, yeah, I've been messing around with Terraform, obviously, like we already said. And what we'll be deploying is an AKS cluster, a public cluster, but we'll be securing the endpoint using authorized IPs. I have some Terraform logic that will query my IP and will add it to the cluster, so I don't have to hard code it. You can just, after this video, download this code. I'll add the link in the description. And it's completely configured, so you don't have to do anything. All you have to do is log into Azure, which we're going to be doing shortly. And then you can just do Terraform apply, Terraform plan if you want. What's not included is a storage account to save your state. So this is not production ready or anything like that, right? So the state file will be in the Terraform folder because there is no backend configured. So,
okay,
otherwise it wouldn't be easy to reuse it.
No. Right? So what we're saying is this is like home lab, POC, dev environment, right? You want to become familiar with the Terraform command line interface. It's always a good place to start. So a plan and apply. And what we've talked about before, maybe, and we've mentioned it, that Terraform uses something called a state file, right? And this state file is going to be local backend, right, Robin? Is what we're saying.
Exactly. Thank you for summarizing that. But that's exactly what we're doing.
Awesome.
It is, well, it's a little bit beyond home lab, to be honest, because I was coding away and I spent some weekends working on this. And, there is some nifty things, but what I tried to stay away from was modules and modules calling modules and for each loops and other Terraform logic that's not that easy to digest and that needs a little bit more time to wrap your head around, right?
Okay.
So let's let's look at the code. So what I like to do in projects like this that are a little bit simpler, that don't have modules, is I split up my resources across different files. So it's easier to navigate and it's easier to find certain resources instead of really one long main file, right? So I do have a main file that includes like the provider configuration that we'll look at and some other things. And then I added the networking bit into the networking file, Kubernetes bit in the Kubernetes file. There's a key vault. We're using a customer managed encryption key for the encryption of the nodes. See, that's beyond home lab. There's an outputs file and there's a variables file. And awesome. In the variables, there is some logic. So you can change the default region. I'm deploying to West Europe because that's the one closest to me. There is some location abbreviation logic because I don't want to spell out the whole name in case of naming restrictions. So if it's West Europe, it will add this, etc. This is not an extensive list. So if your region is not in here, it will default to not available. You will see that as well in the code. The environment is dev. I just like to start with dev, right? But you can change this to whatever you want. The Kubernetes is free tier to minimize the amount of costs associated with this deployment. And we're using a standard D2S v2 instance size, which we can also modify here. So that's all I have for variables, right? And what I try to do here is, it could be that you want to change the size of your instance for prod versus non-prod, right? So what I then do is I create variables for these specific variables, whatever, for this specific information. So then when I run my pipeline, I can add some logic in my pipeline that will change the variable when calling Terraform plan, right? So this way I can manipulate certain variables while I'm deploying my Terraform code. Because ideally you use exactly the same code base for all your different environments, but sometimes, because of economic reasons, cost associated reasons, you want different instance size or, different configuration for production versus non-prod. Does that make sense, Kev?
Yeah. So basically, instead of having that hard-coded manifest file, you variabilize the solution, right? Depending on the scenario that we're going to be deploying towards, right? So like you said, the compute size, right? You could change that up and down depending on your requirements.
Yeah, there's a little bit of a backstory there because it's always a balance between, okay, am I going to create modules for everything? Am I going to create variables for everything, right? When do I create a variable? When do I just hard code it or use a local block? Or, there are so many ways that you can achieve the same thing. And I'm always trying to challenge myself as in, okay, what is the right approach here? And when I started out with Terraform, like quite some years ago, I variabilized, is that a word? Anyway, yeah. I created variables for almost everything. So I went completely bananas, right? I create modules with outputs and I string the whole thing together. And now I'm trying to find the right balance between, okay, what's needed here? And what's just plain and simple over engineering, right?
I completely agree. I'm seeing it more and more. Like the saying goes, too many cooks in the kitchen spoils the broth, right? It's like engineers love to over-engineer everything, right? And it just, some of the Terraform manifests I've seen, right, or the module calling, it's taken to a new level, right? To the point where Terraform's doing stuff now that it shouldn't be doing, right? People are making it as complex as possible. I mean, I sort of live and breathe by keep it as simple as possible because it could be 6 months before you come back to it, or you've got to hand it over to another member of staff, right, or somebody on your team. How do you reverse engineer it, right? Something doesn't need to be complex to be valuable, right? From a resource or configuration point of view.
And contrary, I think that simplifying complexity is one of the ultimate goals, right? Because if you add all the different pieces eventually, right? So, okay, for our application or for my organization, company, whatever, I need to deploy a Kubernetes cluster. So I have to deal with networking. I have to deal with a whole lot of things, right? And I don't even have an application running then. So then I have application on top and the complexity of Kubernetes added to it. And I haven't even discussed automation. So how am I going to deploy everything? Layered deployments, Terraform state, right? Which are global resources, whatnot. And before you know it, you have this really complex collection of technologies and tools all responsible for this solution. And then if you also over-engineer modules, calling modules, and stuff like that, then eventually it works, but it's really difficult to troubleshoot. It's really difficult to onboard new people, etc. But I think everyone gets what we're aiming at, right? So yeah,
keep it simple.
Yeah, but of course, then is this keeping it simple, right? You understand what I mean? So I create a map, and based on conditional, I pull this out. So there are some other things because Terraform is so extensible, you can go completely crazy, right? And that's what I really love about Terraform is the support for a lot of things. So if we go to main, we'll start with the providers, right? So Terraform works with providers for different providers. Well, in this case, we have one for Azure called Azure RM, right? That's the Azure Resource Manager provider. This is how I usually approach versions in this case, right? You can pinpoint them or you can create different configurations here. This is basically saying 3.43 and anything above, right? Because I hard-coded it once and I had to go through everything to change it again. This can break stuff, but this is how I like to do it for now. In production, I pinpoint it. So I load in the Azure RM provider. I load in a random provider that you will see later on. And I loaded in a HTTP provider that will go out, query my public IP address, and will add it. So you'll be seeing that as well. Then I enabled a resource group feature for the Azure RM provider, which basically says that it can delete a resource group even if there are still resources in there. Normally you don't want that, but because I highly suggest you to start working with this code and also destroying everything when you're done, because we enable container insights for the log analytics workspace. That's also included. The resource group cannot be removed because that's a resource created outside of Terraform, and Terraform is like, but I want to remove this resource group. There's still something in there what's not managed by me, and so that's why I enabled this. Don't do this for production workloads, right? For stuff that you need to delete. Oh, for stuff that you want to keep, basically, I have to say. Then I use this data block to be able to query some of my client configuration further down the line. That's needed for, I guess it's my key vault access policy, if I'm correct. We'll get there. And then, the first step I'll use that HTTP provider that I loaded in here to go out and fetch my public IP address. All right, so Terraform will do that for me. No scripting, just how do you say that? Built-in Terraform functionality. Then I have an app name. I went for Orion. You can go for whatever is applicable here, but I had to come up with something, right? And here you see that location abbreviation. So what it will do, it will look up and set the location abbreviation defaults to not available. So what it will do, it will go into my location abbreviation variable that we just looked at, right? I can open that in another window. All right, so what it will do, it will look up the region in this map. Right, so this is a key value pair, just like Azure tags, for example. And you can do a query. You can look that up. So what happens here? Where are we here? So it looks up, it goes into that variable. It will add the location, which in this case is West Europe, and then it will spit out the WEU abbreviation. If it's not available, it will not error out. It will try it. If it's not there, it will default to not available. And this is not Northern America, right? This is not available. So yeah, I had, some nifty little things that I added here. Then I construct a name suffix. I like my naming.
Yes.
And I don't want to go into all resources. If I decide to flip this around or change this, I can just change this, and then it will be added to all my resources further down the line. So reusability, right? Then I clean up my public IP address because there is a new line character behind it, and Terraform doesn't really like that. So this is a function to clean up new line characters and spaces. And then I set the authorized IP range for the Kubernetes cluster. And here you see my local IP address. That's this one, right? Because this is in my local block. This is my public IP. Cleaned it up, right? Because this is my data HTTP public IP. Data HTTP public IP. And then the response body. So the response of this, curl wget HTTP request, right? Whatever it uses. So that already pre-configures my authorized IP range. So this way, person who will use this and will run this will add their own IP address. So it's not hard-coded. That's what I try to achieve here, right? And I don't really want to submit my IP address to a repo. I did anyway, right? Who cares? It's not a secret. Yeah. The whole internet knows your IP address, and then suddenly we all get skittish when we talk about IPs.
You're getting your 1 in 2 weeks anyway, so don't worry about it.
Yeah. All right. So then the next one, because the storage account, we have to speed up a little bit, otherwise we'll be talking here for a long time. I see a comment here. What's up?
Hey.
And by the way, this is two-way traffic, right? So if you have questions or you want me to elaborate a little bit more on something, then let me know. I just name the file and the line number, and I will get there. No, I'm joking, but just let me know. And by the way, I'm monitoring the chat because somebody didn't log in. I'm not naming anyone, but so let's continue. I generate a random suffix for the log storage account. Storage accounts need to have a globally unique name, right? So what I do, I create some random digits, and I'll use them further down the line. Right. I do the same for my key vault, right? So this minimizes the chance of a naming conflict. By the way, this is byte length 3. I'm using hexadecimal, so this turns into 6, but you'll see that further down the line as well. Then, hey, how can we deploy anything without a resource group? And here you see what I do, right? RG, and then I put that local suffix behind it that I construct.
Further up the stack,
I construct here. So that's that reusability component. And then boom, log analytics workspace, because you have to take care of your logging. All right, same local suffix behind it. Retention in day 30, it's default 30, but I added it here so that you can change it if you want, right? Okay. I think you can go to 30, 90, 7, 90, something like that. A little bit more about that soon. Then I create a storage account for the logs. So what I do, I abbreviate it, prefix with the abbreviation ST. That's, by the way, the official abbreviation for Microsoft. That's what I'm trying to use as much as possible if it's available. Local app, so that's the name from the suffix. Variable environment, also from the suffix. Then a random ID storage account.hex, right? So there is where I look up that random ID here. Random ID storage account, byte length, and then I grab the hex. So you can grab different values out of that randomized
combination, right?
Yes, but hex makes sure that it's just numbers and letters, right? So no weird characters or anything like that, because most naming restrictions don't like that.
With storage accounts as well, the name has to be unique.
Yep.
I mean, how many times have we tripped over that, right? I don't know, when you start out in Azure and you're trying to deploy a storage account. So having this logic built in is really good.
Turn this off, highlight mode off. Come on, leave me alone. All right. So what I did, location, resource group, standard tier standard, and it's a local redundant storage, right? So usually you don't want this, but because we're trying to do this as cheap as possible, LRS it is. Then I create a managed identity for the Kubernetes cluster. Why am I doing that? The cluster creates a system assigned identity, but you cannot, it's easier to create a managed one and then reuse that. Otherwise you have to find some logic to figure out that system assigned identity. And we need this identity to give the cluster permissions on the route table and the subnet, if I'm correct, because I'm using a custom network. I don't like that Kubernetes. If you just do a standard cluster deployment without a custom network, it will create a network for you. I don't like that behavior, to be honest, because normally you have to integrate it, right? So overlapping IPs can become troublesome and stuff like that. So you want maximum control there. Then, why not? I was messing around with customer managed keys and encryption. So to encrypt disks, you need to create a disk encryption set, and that needs an ID. That needs an ID to talk to the key vault that contains the key. So that's why I create this managed identity. And then I create the disk encryption set. Right. Okay. So auto rotation is enabled. User assigned identity. It's referring back to that identity that we create here, right? This one. And it depends on a key vault access policy, because otherwise it tries to talk to the key vault without the policy being there.
I take it back. This is not a home lab. I would say this is a very good place to start with a dev. It's a good foundation. You've got a good mixture of resources in there. You've not only got the cluster, you've got the log analytics, right? For the logs, you're using Key Vault for the encryption management.
Yeah.
Again, maximizing that control over the virtual network, the subnets, the route tables, that kind of thing. Because in most enterprise environments, you already have a landing zone. So this is a workload that you're deploying onto that, right? So you need to take that into consideration. And I love the fact that I say variabilized, it's probably not the right word, but the way you've got all the unique strings in there and the logic built into this, it's going to stop you from tripping up over your own shoelaces. Because as we know, as you're going through the deployment stage, either that be with Terraform or through Azure, then getting those naming right on some of those items is critical. So,
yeah, exactly, completely agree. And this, I took some years for me to reach this point of reusability and naming and some logic that I add into Terraform. And we can go even crazier, but it still needs to be digestible and needs to be understandable, right? So I think this is a right balance. Ideally you create modules further down the line for these components, because it makes it easier to reuse certain components. We'll see that as well. But network bit, right? What this is, it's a virtual network with an IP range, a subnet called AKS with an IP range that falls into the address space of the network, obviously, otherwise we cannot deploy it. A network security group, a route table, associate the network security group with the subnet, and associate the route table with the subnet. You can create a subnet inline into the network, but I like to do it separately because otherwise it becomes messy, right? And then what I do here, assign the network contributor role to the managed identity, the subnet, and route table. So this is for the subnet and this is for the route table. So this way, the cluster that's going to use that managed identity has network contributor rights on the subnet and route table, because that's what it needs, right? Otherwise, it doesn't have access, it blows up. Because it will add stuff to your route table. And it needs to access the subnet to, I think, know which route table it's associated with. And if you don't add a route table yourself, it will create one for you. But hey, like I said, I like to create my stuff myself. This stuff myself. So, all right, that's the networking bit. we'll keep Kubernetes for the last, right? Then some key vault stuff. Because usually you're going to use, well, ideally you're going to use Key Vault to manage your secrets, right? You can go with Key Vault Standard and Key Vault Premium. So if you need FIPS level 2, then you can go with Key Vault Premium and you create HSM-backed keys if needed. Or you can go manage HMS or HSM or dedicated HSM, whatever. But I was like, hey, let's already add a Key Vault. And let's use that Key Vault for the customer managed encryption key that we're going to be using for the encryption of the nodes. So what I do first, because I like to enable diagnostic settings, but every service has different logs and metrics, right? And I'm not enabling metrics. Metrics is only applicable when you want more advanced querying capabilities than Azure Monitor gives you, right? Because otherwise your metrics end up in your log analytics workspace, and usually you don't do anything with them, and you go to Azure Monitor anyway. So because every service or resource has different logs available, you don't want to be figuring that out all the time, and you don't want to forget anything. So what you can do, you can query a resource ID, and then it will return you the available logs and metrics. Then I'll set them. So that's a specific end, log underscore categories underscore types and metrics. So I create a local one. And why do I do this? Because it's cleaner. And when we look at Kubernetes, I use the same approach, but I remove the kube audit logs because you don't want them into your log analytics workspace. You want your kube audit logs to a storage account, which is documented by Microsoft as well. This is like the quote unquote best practice. Then we create a key vault. Right, soft delete. Yeah, we need to enable this. So soft delete is enabled, 7 days minimum, and purge protection is enabled. Otherwise, you cannot use your key vault for customer managed key encryption. Something else what I like to do is I like to enable premium. This doesn't do anything with the cost associated with your key vault until you start creating premium keys, HSM-backed keys or RSA keys above 4096, whatever. But I like to do this because then I don't have to worry about it. And if I need keys with a higher, security rating, whatever you want to call it, then it's already there. Then I create a key vault policy for the current user. So that's the user that we're going to log in with. That's my user account in my own Azure tenant. And here you see that Azure, the data block that we looked at the beginning.
For sure. Yeah.
All right. So we have this data block that will just store the information of the session that we're using to deploy resources to Azure. So, and here I use that. So I look up the tenant ID by querying this, that data block, and saying, okay, give me current tenant ID and give me current object ID, which represents my user, right? And I give myself some key permissions, so I can create, delete, get, purge, update, and sign keys. Can probably strip this a little bit more, right? Principle of least privilege and all. And then I create a key for the disk encryption set. Right, so this is the customer managed keys. On this way, it's a Terraform managed key, but right, it's not a platform managed key. Sorry, this is the access policy anyway. And here we create the key. Sorry, messing up things. But access policy for the managed identity that's associated with the cluster. Sorry, managed identity that's associated with the disk encryption set. I'm messing up things here. So once more, access policy for the managed identity for the disk encryption set, so that it can go out and get the key, unwrap the key, and use the key, right? Then the key itself. It's an RSA key, so this is not, if you change this to RSA HSM -HSM, then suddenly you have an HSM-backed key, right? And that's the power of that key vault premium. And then the key size, 2048. Some key options and some dependencies, otherwise everything blows up. And then the diagnostic settings. So this is what this is like some dynamic block and a for each statement. So we do have a for each loop anyway, but What it will do, it will go to local key vault log categories. So it will loop through that. And here we have local key vault log categories. So it will loop through all the available log categories and it will enable them. Right, and it will also go through all the metrics, but it will leave the metrics off. And why I do that, I want to add it. And if you don't do it, then you will see that metric block coming up in your Terraform apply and Terraform plan all the time, right? So that's why it's added there. It's a little bit of a bug. And then save the best bit for last, right? So here we have the diagnostic setting approach again that we just saw from the key vault. But in this case, I'm doing some logic to disable or to leave out the kube audit log, right? So it will go through the diagnostic categories, log types. And if the type doesn't equal kube audit, it will add it to that local variable. If not, it will leave it out. So when we deploy it, we're going to do that in a couple of minutes, and you'll see that the diagnostic setting for kube audit is disabled or not enabled, if you will. And then the metric categories as well. And here we have the whole cluster block, and then we have the diagnostic settings. Yeah. Right. Okay. Yeah. Makes sense. Okay. So this is the this is where the magic happens, so to say. Right. So this is the Kubernetes cluster. I named it default. Then we have AKS with the local suffix behind it again. Right. Keep seeing that coming back. If you don't define this one, then you get this strange M capital M capital
random
C
generated. It's horrible. Yeah.
We don't want that. So what I'll do, I'll just grab the resource group name, and I put -AKS behind it. Then we have the DNS prefix, the tier, which in this case is free, right? This is defined in the variables file. Azure policy enabled, really important.
Yep.
Sweet. And here we have the disk encryption set ID that's being used for the encryption. Then we have the default known pool, right? With the name of default, how inspiring. And then we have a VM size. That's the one defined in the variables file, right? Remember here? All right, so let's go back to this one. So what we do then, define the VNet. This is the VNet that we created in that networking, in the networking file, basically. And what I do, I deploy this default node pool across 3 zones. So I have, within the region, a highly available cluster. So it's not a regional available cluster, but it's spread across 3 availability zones. So if the whole region goes down, cluster is gone. But if one of the zones fails, then cluster will remain running. Autoscaling is enabled. Minimum node count is 3, and maximum node count is 9. Right. So if you're experimenting with this yourself, you can change this, right? I got sponsored some credits because of the Azure MVP award, right? One of the benefits. So for me, it doesn't really matter too much. And if I keep this on all day, then I will run through my credits as well. But this, you can mess around with this. So if you want a cheaper solution, then you can use this. Or if you just deploy this and delete it again, then you're fine as well. Define an upgrade setting. So in case I want to upgrade my AKS version of my nodes, then it will scale up for 25% above this 9 if needed, right? So we'll go to, what is it? Something and a half. But anyway, then the identity, user assigned. That's the identity that we defined in the main file. API server access profile. This is where we configure the authorized IP ranges, right? That includes my public IP address. Then the OMS agent for container insights. And then the Microsoft Defender for Microsoft Defender related functionality that you can enable in the log analytics workspace as well. Some dependencies, because subnet needs to be there, route table needs to be there, because that's what the AKS cluster expects, right? And this is not explicitly, you have implicit and explicit dependencies. This is an implicit dependency, because here it knows that it needs to have the log analytics workspace present before it can deploy the Kubernetes cluster, right? That's just defined in your code. But this subnet and route table are not defined anywhere. No, VNet is, but I do need my subnet and route table to be present. So Terraform will make sure that it deploys that before it starts deploying my Kubernetes cluster. So otherwise, in certain scenarios, it can start deploying your cluster and then realizes like, oh, I need a subnet and I need permissions to that subnet. So why is this not working, right?
No, for sure. I mean, I use the depends on quite a lot because Terraform trips over its own shoelaces sometimes, as I like to call it, right? So it's to ensure success, right, when you're deploying.
Yeah, I do like, well, I would like to add that be a little bit scarce or how do you say that, Gav? Don't go crazy on your depends on. I just use it whenever you need to because it makes sense. But otherwise, Terraform will handle most of it itself.
For sure.
And then we have 2 times the diagnostic settings, right? Okay. So 1 time excluding the kube audit logs, and 1 time including or only including the kube audit logs. So this one is going to a storage account because we do want to keep our audit logs, but not in the expensive log analytics workspace because this can become pretty expensive fast. And the rest is going to a log analytics workspace. Right, so we create 2 different diagnostic settings, 1 excluding kube audit and 1 including kube audit. First one going to a log analytics workspace, second one going to a storage account. So let's do this, right? AZ login. There we go. Logged in. Look at the AZ account list output table. Let's see, I'm not using the right subscription. So let me change that. Copy this.
Just set the context, right?
And set subscription. Paste this in, boom.
So just to touch on what you've just done there, right? So when you're in Terraform, so when you want to use Terraform and you're using the command line interface, you've got to set the context, right? Because when I first started using this, I was like, how does it know? Right? like someone just went, it knows where Azure is, it knows which subscription to use, right? Blah, blah, blah. And I was like, but how? So when you're running commands inside the context of your terminal, right? Command line interface, like Robin's just in there, right? He's logged into Azure. So he's got a token now to access his Azure environment because he authenticated through the web browser. And now he set the subscription context to the subscription ID that he wants to deploy to, right? And you've also, just so we haven't missed anything here, you've also navigated. Your working directory, right, is set to this repo that you've cloned locally, right? Because that's how Terraform understands where the manifest file is, right? So,
it's good that you take a step back because I can dream this stuff, right? So, to go back to that, so if you open my Finder, I have a code folder that I like to put my code in. I have a GitHub one, my own. Right, and here we have the folder that I'm currently in. Right, and that includes the Terraform folder with the files that we're looking at in GitHub, right? So if I remove this and I say present working directory, then it will tell me, hey, we're in my users, Robino, code, github.com, Smorenburg. I usually fuck it up in English anyway. So this is Smorenburg for anyone who likes to know. Pathway to AKS, deploying with Terraform, and then Terraform, right? So that equals this directory that we're currently in. And that's also the directory that I opened with VS Code, right? So we could have gone through the code here as well. But hey, potato. So what I would like to do now, if that makes sense, first.
So your Terraform files in that folder, right? If you do like an LS, will it have the structure, right? I take it.
Yeah, boom. There we go.
Right. Okay.
So, and you need to initialize Terraform in the directory that contains your files, right? So we do Terraform init, and then it will start pulling in the providers that we define, see, including the versions. So Azure RM, random, HTTP. Then it's installing the providers, and why it is so slow. Anyway, Terraform has successfully initialized. So let's go to Terraform plan. That will tell us what it's going to create. So it will first, look up my public IP address. Okay, that's done. And then the rest is now computing, so to say. And I think what's really good to keep in mind is that the files that we see here on the side, right? Key vault, Kubernetes, main, network, output, and variables. You can name this whatever you want. You don't even need a main file. What Terraform will do is it will just, how do you say that? Merge everything together, and then it will run it, right?
It's logic, right? It sort of pins all the dependencies together, right? Like it knows from top to bottom what it needs to do.
Yeah. All right, so here we have the whole list of resources, right? Everything that we just looked at. I'm not going to go through all of them, but let's go down here. 24 resources to add. Let me add this and let me deploy this, and then we can talk because it will take a couple of minutes.
Sounds like a good idea.
Apply. I say auto approve because I don't want to say again, yeah, sure, do it. Right. So now we'll just go and deploy.
So I always love doing a plan for damage control. Some folks like jump into the apply because the apply does a plan as well, right? But I find it, a great way to validate your code to make sure that the dependencies are all going to work, right? So, and it also gives you that output, right, of this is what's actually going to happen. So checks against the current state, and it checks against, what's actually deployed in Azure, and tells you what the differences are going to be. So like we've got 24 to add, 0 to change, and most importantly is 0 to destroy, right? So I use this quite a lot when I'm, say if I'm talking to a customer and I have a piece of infrastructure, I've already got it deployed, and they want to implement a feature, right? Or a change to that infrastructure, but they don't know what the effects might be, right? Because sometimes you have to configure resources in a certain way at the point of build or deployment. Terraform's really good at telling you if it's got to recreate the resource, like tear it down, destroy it, and rebuild it with a new configuration, or amend the existing infrastructure. So I always love to do that because it gives me a clear boundary of this is what you need to do, right, to get to your desired state. So, yeah,
absolutely. And another thing to add there is that you can output a plan file, right? So if you're looking at CI/CD, multi-stage pipelines, that sometimes you want to look at a plan file before you approve the deployment, right? Especially in production environments. So what you do then is you create a plan file. That plan file is the artifact for the next stage that has a manual approval on it. So before that stage is going to run, you need to approve it. So you can go back to the previous stage, look at the output of your plan file, like, hey, is this indeed what I expect it to be? And if so, then I can approve the last step, and then it will deploy all the resources, right?
Also great for change management.
Sorry, I don't know. I have no idea what that is.
Well, some organizations still have those change boards, right? They're not all agile, Robin, right?
You're breaking up, man. I hear dude. I have no idea.
But like what I found is when I was in those situations, you turn up with that plan, it's in black and white, right? Especially if it's got to go through some sort of security approval as well, Robin. Like, you're making changes to firewalls or NSGs. I'm just playing devil's advocate here, right? But yeah, it's good to go with the evidence. I love putting this in front of those folks because it's written down in front of them exactly what's going to happen.
Yeah. Yeah, so it's I love Terraform. Even though we had really great sessions about Bicep, Alex came on. Bicep as really great
leaps and bounds. Yeah, leaps and bounds. It's come on, right?
But I don't know. Somehow there's something about Terraform that just makes me smile with the extensibility and also the documentation. Because while this is creating, I opened it here already. We haven't really looked at it, but the documentation is so good, right? Oh, I should not type. Oh. For example, the Kubernetes cluster, and if you go to the portal and look at it, and it's easily you easily look over certain configuration items. And it happened to me in the past that when I went through the resource in the Terraform documentation, this one is zoomed as well. No, it's not. Nice, right? Am I using this without zoom all the time? I am. Yeah. Geez.
That's why I put my glasses on. Sorry.
No, but I'm sorry about that, guys. So at least you can browse to the repo yourself. But I haven't really thought about that a new tab will open. Will reset my zoom basically. But all right, let me circle back because
go for it. Let's go back on track.
ADHD and all. But so what I like to do sometimes when I don't have anything to do or I need to build a certain solution is I go through the Terraform documentation for that specific resource. First of all, I have an example here, which is usually a great way to start. But if you go through this and you read all the explanations, then you know exactly with which settings are available, right? And which things you need to think about. And then some of them are required, right? So that's why I add them. Some of them are optional but have a default value, right? And I just go through all this like, hey, okay, I have an ACI connector if needed, Azure Container Instances, right? Automatic channel upgrade, like, hey, I have a way to, define my upgrade channel for this Kubernetes cluster. Defaults to none, right? So if I don't add this to my configuration, which I didn't, it's optional. But if not set, it will set it to none, right? And whenever we won't go through everything, let's see how our deployment is doing. Okay, it's creating a cluster. Usually takes around 4 minutes. So,
but I know what you're saying. I do this as well because it feeds into the requirement gathering, right? So, especially if you're dealing with something new that you haven't really dealt with before, you just go through this list, right? And
exactly,
at least you feel more informed, right? You normally got more questions at the back of it, right? You're probably Googling what each one of these features do, right? But it's understanding the capabilities and the art of the possible, right, with that particular resource that you're deploying.
Exactly. And it wouldn't be the first time that I would find out about a specific, feature or a specific setting in the Terraform documentation, because I was never, it was never presented to me before when I went through the documentation provided by Microsoft, right, or Microsoft Learn or anything like that. So anyway, the main point is, bottom line, documentation of Terraform is really great. Terraform in general is really great. So let's see, this is almost done. Let's circle back to our resource group.
Yeah, let's see what's been deployed. Let's take a look.
So this one is still being deployed, right? So whenever it's done, we can connect to it. And we've got this whole list of resources. So it's quite something to start with. But we have our cluster, right? Then we have the Container Insights Log Analytics Workspace solution that's enabled because we pointed our Container Insights to a Log Analytics Workspace using Terraform. That's the OMS setting in the cluster resource. Disk encryption set. Sorry, I need to drink some water.
It's okay.
Yeah, and if not, then, I'm sorry. All right. Disk encryption set that we need to encrypt our disks. The ideas that we talked about, right? And managed identity for my AKS cluster and a managed identity for my disk encryption set. Then we have our key vault containing our access policies and our, our key. So we can look at that as well. Oh, that's nice. I haven't added myself as list, so that's good. We can do that. Let's add that, right? Key vault. So I didn't add myself with list. Let me add that under get.
Changes on the fly.
Yeah. We can redeploy this after our deployment is done. So it's done.
That's pretty good for people to see, right? So there should be one to change.
Oh yeah, I already auto-approve it, but we'll see indeed that it's going to change one, and we'll see some some noise, some diagnostic setting noise. That hey, maybe we should talk to Mark about this. Mark, I'm not so happy with certain behavior of the Terraform provider.
Poor Mark.
Oh well, we were thinking about reaching out to him anyway. So, Mark, if you hear this, no, we'll get to it. But what it will do, let's see. All right, there we go. Terraform will perform the following actions. It will update my access policy, my default access policy in place. So here we'll see it add list, right? Because that's what we just added.
Okay.
And this is the diagnostic setting noise. So you can forget about this now. Oh, hello. Why this is happening? Yeah. What happens now? There we go. Anyway, that's already been deployed. So I should refresh this and there we go.
So look at that, like magic. I love that, right? You know, when you do that for infrastructure as a code, you make those changes and then you just hit refresh on the browser and magically it appears, right? It's such a great feeling.
You can even look at it, right? I'm going to destroy this anyway, so it doesn't really matter. No, we cannot look at it. It's a key. Dummy. It's not a secret. Anyway, this is the key that has been created, right? And if we look at the access configuration, access policies here, then we see that ID, the disk encryption set ID that we created. And hey, yours truly, that allows us to look at the information in the key vault. But anyway, let's circle back, right? So key vault, including everything we just looked at, log analytics workspace, NSG, a route table, storage account for the cube audit logs,
right?
And the VNet, right?
Your trusty VNet, right, to underpin everything, right?
Yeah. So if we look at at the subnets, for example, and we look at this subnet, then we see that it, as this network security group associated with it, route table associated with it. Hey, we're missing some available IP addresses, right? So if we go to connected device, like, hey, these are our instances, right? Deployed in that subnet. Something we haven't discussed yet, but would be interesting to look at after this this video or this episode, whenever you're watching this. But I'm using the KubeNet network plugin. Net container network interface CNI, but I'm using the KubeNet, which means that all the pods are behind network address translation. So they don't have an IP address in a specific subnet. The nodes know how to find your pod that's running on them or in them, whatever you want to call it. But the other option is the Azure CNI. And then your pods are directly associated with your subnet. So they get an IP address from that subnet. And it does give you a lot of other benefits. Right? We discussed this with Steve last week. Steve Buchanan. We went through like the AKS scenarios and strategies. And one of the things that we discussed was networking and pods and also the Azure CNI, right? So with production deployments, most of the time you want to go with Azure CNI because that will just give you more features, more control. Your pods are not behind network address translation, and performance-wise, it's a little bit better as well if you're really looking for that edge from your networking perspective, right? So with that, we can look at the route table, by the way. That's funny. This is what the AKS cluster did, right? This is what AKS did. That's why it needs network contributor permissions on the route table.
Right.
To be able to add the address prefixes of nodes. And what is this? I think this is the address prefix of the pods running inside of the cluster. But yeah, with that, let's connect to the AKS cluster so everyone can see that it actually works. Right? It will ask me to, set my subscription, but hey, that's what we already did. So then I will just copy this, go to my terminal, paste this in.
That's what I like about that workflow there as well. Like, here's the steps to connect to your cluster, right? Get you up and running.
Already connected. Okay, this is my alias, right? For kubectl. This makes my life easier. Okay, add all in all namespaces.
Nice.
This is our out-of-the-box cluster, including Azure Policy, metric servers enabled here, the Microsoft Defender collector that we enabled. What else do we have, right? Gatekeeper, container storage interface, drivers. So yeah. What else? This is it. Let's see if I do output wide. I think that works. Yeah, it works. I wanted to look at the IP address, the pods. Doesn't matter. We can skip that for now. Let's see if we
a lot of information there.
Yeah, it is. This is unreadable, I know. Oh, here we go. See? Let me zoom in. Zoom in. Yeah, let me zoom in again. Oh, this is working. Nice. Oh, there we go. Zoom in again. A bit more. Scroll down. Here we go. So our pods have an IP address of 10.44, right? And if you look at our route table, we'll see that that's added. See, 1044.
See.
Yeah. So that's it, man. Within the hour. Jeez.
That was awesome. Some really good practices in there as well around encryption and monitoring. I like the fact that, you touched on the permissions required across dependencies, such as, the AKS cluster and the permissions it needs to the root table? Yeah. So giving it the right permissions with network contributor. I like the randomization of all the names and variables for that kind of stuff for your resources. I thought there was some great logic around that. And I really like the fact that it went off and found your IP address and added it to the whitelist to say, yes, give me access to XYZ resources, right? So the amount of times, you deploy resources and it trips you up, right? Because you're going in there to try and modify them or trying to understand what at the data plane level, right? What's happening underneath the hood. So very well thought out. I knew it was going to be great. I knew.
Thanks, mate.
But yeah, It was good, man. I've learned some stuff.
Well, the thing is, even though that I work with AKS on a day-to-day basis, I learned a couple of things from doing this myself, from preparing this code, preparing the demo, thinking about certain things like, hey, okay, I can mess around with that. Oh, I can mess around with this. And I was hard coding my IP address, right? So if you go through all the history of the repo, you'll find my IP address. But then I was like, hey, that can be easy. Yeah, okay, we can add scripting within Terraform, right?
Yeah.
Local exec, but Terraform or HashiCorp specifically tells you like use this only when there's no other option, right? So, and then I came across that HTTP provider that you can load in, and then like, hey, I can query my IP address going to this specific website, right? And it will just return my IP address. Because the recommendation is to use a private cluster, which from a security perspective is awesome. But from a management perspective, a pain in the ass, right? Because then you get like jump host and Bastion or VPN and stuff like that. Right, so this setup is really great for development and getting familiar and comfortable with. And then you can always look at a private cluster, but that means you don't have a public endpoint that you can talk to. So you need to connect to something that's running inside of your network. You need to deploy Bastion. You need to deploy a VM, right? And if you expose that VM directly to the internet, then you can just expose your API endpoint because then
Right.
So then the cost associated with your home lab deployment will go through the roof. Right? So I think this is a really great way to do it. It's extensible, so if you want to add more IP addresses, you can just add it to that local block. Right? And if you want to use other variables, or you want to how shall we? What is the term? I keep going on verbalization. No, variabilized, whatever.
Variabilization. We'll just make a word up on the spot, right? It sounds good. Let's go.
But anyway, I enjoyed doing this. We can even build on top of it, but the producer of the show said that we should focus on some other things instead of just Kubernetes all the time.
Watch us do another 6 episodes on Kubernetes now, right? Watch. But yeah, no, we are going to build on it. I really like doing these technical sessions. I feel like folks get a lot of value out of them, and I always learn something new. I mean, it's great. So thanks for putting the time and effort in, Robin.
You're very welcome.
And again, if you've got any questions, hit us up in the chat. Or again, don't forget to like and subscribe if you think this is valuable.
Yeah.
And also, look at that.
Sorry, I just had to
do my Prince impression then, right? But then, but yeah, hit us up on the community as well. So if you want to join the community, come and ask. Like, the Kubernetes channel in there is always bouncing, right? So community.streamingclouds.io. Come and join us. Come and ask questions if you want to know a little bit more about it.
Absolutely. And if you like what you see, we got a question.
Right at the end. Thanks, Jeff. What have we got here?
What's your opinion on deploying Helm charts with Terraform? Very interesting. Don't do it. No, it's Helm is deployable using CLI and there are other ways, but you can also deploy manifest files using Terraform. But somehow that feels like trying to get a nail in the wall with using a screwdriver instead of a hammer, right? So it does work, but is it the right tool for the job? So I would say no. Kev, you?
I tend to find if you keep your stages of deployment separate, it ensures more success. So use the right tool for the job. I think that's what you're getting at as well, right, Robin? Like, try and use the most aligned tool for that specific part of the deployment.
Yeah. I would stay away from Helm charts altogether. No. No, it's a great way to package your applications and to, get stuff up and running quickly. But there's usually so much complexity underneath the hood that if you're trying to figure out what it does and trying to, troubleshoot certain things, or there's an upgrade, then, life becomes pretty complex and challenging fast. So, and then if you add Terraform to the mix and you have a state file containing your Helm charts and stuff like that, then
it becomes messy, right? Yeah.
Yeah, but if I would consider it, I would layer it. So I would have a separate Terraform deployment for my infrastructure, right? Even a separate one for my network and a separate one for you can layer that on top of each other. Way out of scope of today, and then use Terraform to layer up the application on top of my infrastructure. So then you can mess around with Terraform, manifest file, Helm charts, and stuff like that. But don't mix everything together. That's what I'm trying to say.
Some sound advice.
Yeah. Well, Jeff seems to agree. So
let's wrap this up.
And of course, what we always say, there is not one way to roam, right? There are usually multiple ways to reach the same destination, right? And it's not that it's always the same. So yeah. All right. With that, if there are no further questions, then let's wrap it up. I was trying to say, if you like what we do, don't forget to like, subscribe, and hit that bell icon for receiving notifications whenever we go live. And hope to see you next time. Bye.
Bye-bye.